This video covers the concept of momentum. You may have heard of momentum before. If a particular sports team is doing really well, one would say that they have a lot of momentum. If a heavy object is moving, one would also say that it has a lot of momentum. The actual definition of momentum is simply the product of the mass times the velocity of an object. Take note that the momentum here is represented with the lowercase p. You may find this frustrating, but remember that a lowercase m is already used for mass, so we couldn't really use the same variable for two different situations. So also take note that momentum is a vector, so direction matters. The unit for momentum is a kilogram meters per second. The way to remember this is that the SI unit for mass is kilogram and the SI unit for velocity is meters per second. These units put together just makes kilogram meter per second. So let's do an example dealing with this idea of momentum. So a 60 kilogram person runs at a velocity of 2 meters per second. What is that person's momentum? So we know with our momentum equation that is just mass times the velocity. Mass of the person is 60, velocity is 2, so we find that this person has a total momentum of 120 kilogram meter per second. Let's do another example. A 2,000 kilogram truck travels at a velocity of 10 meters per second and slows to 4 meters per second. What is the truck's change in momentum? Now this is asking for a change in momentum. We already know our momentum equation, but we haven't really talked about how to calculate change in momentum yet. It doesn't really make sense for the mass of an object to change, so we know that in order to calculate the change in momentum, we must multiply mass times the change in velocity. Another way to look at finding change in momentum is that we know whenever we have a delta symbol or finding the change in a particular value, that it is always the final value minus the initial value. And to find the final momentum, we would simply multiply the mass by the final velocity. And to find the initial momentum, we would simply multiply the mass by the initial velocity, and we subtract the initial momentum from the final momentum. So to solve this problem, we're going to simply use this change in momentum equation. And we can fill in our known values, and we find that the change in momentum is negative 12,000 kilogram meters per second. Take note that change in momentum can be negative. So let's do one last problem. How fast must a 60 kilogram person run to have the same momentum as a 2,000 kilogram truck moving at 0.5 meters per second? So let's first calculate the momentum of the truck. We know that the mass is 2,000 and the velocity is 0.5 meters per second. So this gives us a total momentum of 1,000 kilogram meter per second. And now we can set this momentum equal to the momentum of the person. So we know that the momentum of the person must be 1,000. We know that the person's mass is 60 kilograms, so we can solve for the velocity, which is 16.7 meters per second, which is approximately 37 miles per hour.